Now that we've talked about lists in more detail, let's take another look at tuples. So for that purpose, we're going to go ahead and use an interactive IPython session. And first, let's talk about creating tuples a little bit more. Now, previously we demonstrated that you can create a tuple by using a comma-separated list of items in parentheses. It turns out the parentheses are not required, with a couple of exceptions, one of which is when you create an empty tuple. So if you want a tuple of no elements at any given time, then you simply use an empty set of parentheses. And when you evaluate any tuple, it's going to display that tuple's contents in parentheses. So as you can see here, we get an empty set of parentheses for the empty tuple. And we can also confirm that it has no elements. All we have to do is use the len function to do that, and we can see that indeed the number of elements is 0. Now let's take that student tuple variable and let's assign it a completely new tuple. Actually, you know what, let's do it without parentheses this time, just so that you can see that the parentheses are not required. So let's say we have somebody named John Green, and we'll assume, since this is a student, that we're going to have a grade point average associated with that student as well. What makes this a tuple is not parentheses. In fact, we have no parentheses here. It's the commas that separate the individual values. Tuples are commonly used to group together related pieces of data, and in the case of a student, this might be the first name, last name, and grade point average of a given student. Now, once we have that tuple, we can go ahead and evaluate it and see the contents, but notice when Python outputs the tuple, it always uses those parentheses, even though they're not required to to create the tuple in the first place. Let me go ahead and recall the len snippet from up above, and now we have this student tuple variable referring to a completely new separate tuple object. I can't modify the existing one, they're immutable, so anytime you assign to a variable that previously was referring to a tuple another tuple, you're just replacing the one that was there, aiming it at a new object. But now we can see that based on the updated object, we have a length of 3 for that particular tuple. Now the parentheses are not required, but we do recommend using them. So let's say we want to create another student tuple, and for this other student, let's put the names in and everything in parentheses. So let's do something like Mary and Red, and we'll give the same grade point average for now. So here we have a completely new tuple that we just created. This time we used parentheses, and of course if we then go and evaluate that, you still see those parentheses in the string representation. Now sometimes you'll create tuples that have only one element, and you may be tempted to simply provide an individual value to represent that tuple. So let's create a variable. We'll call it a Singleton Tuple, and let's say we wanted to just put the string red in there. If I complete this assignment, what I have is a variable referring to a string. So you might say, well, wait, all right, let's put it in parentheses. Well, what I'd have in this case is still a variable referring to a string, because the parentheses are not what defines a tuple. Commas are what defines a tuple. So if you really want to create a tuple with only one element in it, you're going to put that element followed by a comma, and because that's kind of a strange notation to most programmers new to Python, I recommend also putting that in parentheses as well to further emphasize the fact that you're creating a tuple and group those items together. So the way I can tell that this is a tuple versus just an individual string is if the parentheses get displayed around the contents. So if I now go and evaluate that tuple, we can see that indeed the parentheses are displayed, and not only that, in the case of a singleton tuple, it also displays the trailing comma to indicate that indeed it is a tuple. So now that we've shown how to create a few tuples, let's now start talking about accessing tuple elements. Now it turns out that the square brackets we used to access the elements of a list can also be used to access the elements of any sequence data structure. So that could be a string, and in fact we demonstrated earlier that you can use the square brackets to access an individual character in a string, and it can be a tuple as well, and that's what we'd like to take a look at here. Now, to save me a little bit of typing time, let me go ahead and copy and paste here a time tuple, and let's assume these represent hours, minutes, and seconds. And what we would like to do first is just display that so we can see the contents, make sure that it was initialized correctly. And let's assume we'd like to use each of those three values in a calculation. So let's say we want to calculate the total number of seconds based on the current time. So here we have an expression that will do that, where we use time tuple sub 0 to access the element at index number 0 within the tuple. We're going to assume that's the hours and multiply that by 3600 for the total number of seconds in an hour. Then we're going to add to that the result of the next expression, which uses time tuple sub 1 to get the next element in the tuple, and then finally we'll add to that the seconds, which is the last element in the tuple, the element at index number 2. Now when we evaluate that, we can see the total of all of those elements. So you can always use the elements within a tuple by the tuple name, a set of square brackets, and an index number. In the next section, we'll actually show another way to access the elements of a tuple. Again, we'll revisit the concept called unpacking, which we demonstrated briefly in the functions lesson. So now let's talk a little bit about operations that appear to modify tuples. So once again, let me go ahead and do some copying and pasting here to save some typing time. Tuple 1 is going to be a tuple containing three integers, 10, 20, and 30. And let's go and create a second variable, tuple 2, and we'll assign it tuple 1. So first of all, this is a reference assignment. The variable tuple 1 is not the object containing 10, 20, and 30. It is a reference to that object. So what I'm doing here is taking that reference and placing it into tuple 2. As a result of this snippet that I'm now executing, both of these variables refer to the same tuple object in memory. And recall that you can actually check that with the ID function that's built into Python. Now, of course, if I evaluate tuple 2, I can see that it appears to have the same contents as what we assigned to tuple 1 up above, and that's again because they are in fact the same object. So what about an expression like this? Let's say we want to do tuple 1 plus equals, and we want to add to the end of that tuple 40 and 50. Now tuples are immutable. So when you see an expression like this with an immutable object referred to on the left hand side, what's really going to happen here is Python is going to create an entirely new tuple object containing all of the values from whatever object tuple 1 refers to and these new values in the tuple on the right hand side of the plus equals operator. Then we'll have that new object's reference get assigned back to tuple 1, replacing the original object's reference. So tuple 1 currently refers to 10, 20, and 30, but it's going to be re-aimed at a different object as a result of executing that statement. Now, if you simply evaluate tuple 1, you can see that all the elements are there, but you really can't tell that it's a separate object unless you start playing with the ID function once again to check what the IDs of the objects are before and after the operation. And I'll leave that up to you to try out as an exercise. It's one of the great things about the interactive IPython environment that you can just fiddle around like that and learn more. Now, did this modification modify tuple2? Well, let's check that. So we can evaluate tuple2 and see that it's still aimed at the original tuple object. Now, if the left-hand side is a mutable object, like a list, then the plus equals operation works a little bit differently. So let's say I have numbers as a list, and we'll put some values in there. So there's our list numbers, and let's say we want to modify numbers by adding to the end of it with the plus equals operator a tuple of additional elements. Let's say we want to add on 6 and 7. So again, we saw this with lists in the preceding video. When the left hand side is a list, the right hand side has to be some sort of iterable object, some sort of sequence typically, and that could be another list, it could be a tuple, it could be a string, it can be anything that is capable of being iterated over one element at a time. And each individual element will be appended to the end of the list up above. So we can go ahead and execute that and then evaluate numbers to see that indeed 6 and 7 were appended to the end of that list. Now, the last thing I'd like to talk about in this video is the fact that tuples, though they are immutable themselves, are capable of storing mutable objects. So I'm going to go ahead and copy and paste a tuple in here called student tuple. This particular tuple has 3 elements. Amanda and Blue are strings representing a first name and a last name, and this last element is a list object containing 3 grades that of course probably belong to Amanda Blue. So we've now created this student tuple object, and we can access the elements within the student tuple using the square brackets operators. Now, if I use a square bracket and I say student tuple sub 2, well, Amanda is element 0, Blue is element 1, and this last element, element 2, is a list object. Well, if it's a list object, I can use a second set of square brackets in this, and I can go ahead and say, let's say this grade was wrong, 75, so I want to fix it. I could make it 85. So this is going to go to the third element of the tuple, which happens to be a list, then is going to access element number 1 within that list, which is the second element here, and we're going to replace that value with 85. So the list operation of modifying the contents of one element in that list seems to have worked because we didn't get an error message here. So to prove that, we can go ahead and evaluate student tuple and see that indeed we were able to modify that object, because the object that this element refers to is a mutable, modifiable object.